Hey everybody, welcome back. Today we're jumping back to 5-6. We're going to be talking about dilations today, and we're going to be looking at coordinate graphs to do so. Alright, so the very first thing is we have about 6 warm-ups. Here they are. So what I want you to do is pause the video, write these down, answer them. Ready? Go! All right, here we go. So when you do these problems, again, you're multiplying straight across. But remember, all of these integers are all over 1. Don't forget that aspect of it, okay, especially when you're dealing with fractions. So you can simplify these 4s, and your answer is equal to 3. Next one, you can simplify the 12 and the 4 both by 4. This becomes 3. This becomes 1. Set that equal to 9. You're taking 24 times 3/4. Again, simplifying those two numbers because they can evenly go into each other. This becomes 6 and 1. Your answer, 18. Negative 36 times 3/4. Okay, again, simplify here before you multiply. And when you do that, you'll end up with negative 9 here, 3, 1, negative 27. 4 times 2.5, multiply that straight across. Your answer is 10. Last but not least, your answer is 30 on number 6. Again, you are going to get a calculator for your test. Don't forget about that. So you can use your calculators. All right? Here we go. So you are going to learn to identify and create dilations of plane figures today, a plane figure. So as you look at this, one thing I want you to do, I do have the yellow bar up there, but write down what's inside the box. Not what's on top, but what's inside the box. Okay, so write down what's in the box. Pause right now, write it down, and then I'll explain. All right, so as you look at this, it says, do you remember what transformations are? Transformations, there's 3 common ones, the translations, reflections, and rotations. One thing that is huge, it says they do not change the size or the shape of a figure. Okay, they do not. Now, when you look at a dilation, it says is a transformation that changes the size. The size changes, but it's not the shape. Size, but not the shape. The shape stays the same. It's just gotten bigger or smaller. If you think about dilating your eyes, if you've ever gone to the eye doctor and you've gotten your eyes dilated, your pupils, essentially, they get bigger, but it's not like your pupil goes from a circle to a square. Does that make sense? Your pupil stays a circle, it just becomes a bigger circle. All right? A dilation can enlarge or reduce a figure. All right? And that's all going to depend on what your scale factor is. All right, so don't need to worry about writing this down. But I do want you to know one thing here. Notice these 2 shapes. Okay, we have A, B, C, and then we have the A, B, and C at the bottom. And notice how they have this little apostrophe. That's known as your prime symbol. Okay, and when you look at that, those numbers or those letters with those prime symbols means that is known as your image. Okay. The ones without the prime symbol is going to be known as the pre-image. So if you look at the image and the pre-image, which one do you think comes first? The pre-image. Why? It's got the word pre in there. It's pre-image. The image comes second. That's where you're going to see those apostrophes. It all stems from one point called the center of dilation. Don't need to know that as much as you need to know that you do need to include these apostrophes, these prime symbols, when you get your dilation. Okay, so you don't have to write this down. What it says, it says, tell whether each transformation is a dilation. All right, when you do this, again, what is the dilation? A dilation is a transformation that changes the size but not the shape. Size but not the shape. So if I look at this very first problem, okay, notice this is my pre-image. Why do I know it's my pre-image? Because there's no prime. That's my image. So I start at the red one and I move into the blue. Notice my My shape does not change. My size does, but my shape does not. So this is a dilation. Next one, going from, again, the red to the blue. Notice how these two lines, this one, these two sides of this kite becomes steeper. Okay, they come at more of an angle, a sharper angle there. Okay, that's changing of the size. So this is not a dilation. All right, because the shape changed. The size changed as well, but the shape changed. If the shape changes, it's not a dilation. Shape changes, no dilation. Got it? Here's two more. Again, I want you to think to yourself, do you think these are dilations or not? Again, one more time. Shape changes, no dilation. So this very first one, I have the square. Second one appears to be just a larger square. This is a dilation because the shape does not change. It gets bigger. I understand that it gets bigger. But the overall shape of it, the angles here, would not increase or decrease. Okay? Second one, notice that side of the first and the second are different. These two hypotenuses, we'll do that and call them hypotenuses. These sides right here have a different shape. One's a little steeper than the other, so when it does not keep the same shape, it is not a dilation. All right, so we're going to try a couple on your own. Just look to see if they keep the same shape or not. All right, so again, write the directions. I do want you to draw these two figures. Draw the two problems. There's 4 figures there. And then write underneath if it's a dilation or not. So pause the video right now and go. All right, so the very first one, we have A, B, C in red. This is A prime, B prime, and C prime. Okay. And as you look at this, does the shape change? No, it does not change. Size does, shape does not. This is a dilation. Next one, notice, is it different here? Yeah, it looks like we went from a right triangle to an acute, from an acute triangle to a right triangle. Yeah, that changed completely. So this is not a dilation. Okay, not a dilation. Awesome. Don't need to rewrite the directions, just rewrite the two problems. Again, A prime, B prime, C prime, A prime, B prime, C prime. Okay? And try it. All right, so when you look at this problem, this is a dilation, not a dilation. What distinguishes each? The first one, shape does not change. Second one, shape changes. Good. All right, now it says dilate the figure by a scale factor of 1.5. When we, with the P as the center of the dilation. So this is going to be, that's the center. So essentially I'm going to get this figure that looks like this. P prime, Q prime, R prime. All right, and what I do, how I figure out my dilation in my new figure is I take each of those sides and they are going to get 1.5 times bigger. All right, the scale factor is going to change that problem. The scale factor of 1.5, whatever that scale factor is, it becomes that many times bigger. So 1.6 becomes 1.5 times bigger. So I need to take 1.6 and multiply by 1.5 to get my answer of that far side. I need to take 1 times 1.5 to get my answer. I need to take 1.8 times 1.5 and get my answer. Leave my labels in there, okay? And again, they become the same side. So if I look at PQ and P prime, Q prime, 1.6, that's where I'm going to put my 1.6 times 1.5 is right here. So what is that? 2.4 So that becomes my new length of P prime Q prime, 2.4 centimeters. If it has a label, keep the label in there. Has a label, keep a label. Then you have 1 times 1.5. Oh, easy one. 1.5, plug that in, I get 1.5 centimeters. Last but not least, 1.8 times 1.5. When I answer it, I get 2.7. That becomes my new side here, 2.7 centimeters. I am taking this first triangle, multiplying everything by 1.5 to get my new triangle. It's dilating that much larger. Okay, dilating that much larger. All right? All right. Okay, so now we are going to dilate the figure by a scale factor of 0.5. Don't worry about this second problem or the second triangle. Just dilate by a scale factor of 0.5 with G as the center. That center, again, you just know that G is on top. You're going to G prime, H prime, and F prime, but figure out your side lengths and go. All right, so when you take these, you're going to take your 2 centimeters and multiply it by 0.5. Now, do you think you have to take that 2 centimeters and multiply it by 0.5 3 times? No. If we do it once, we're good. We know the rest of it. Okay, so if I'm multiplying those together, I get 1 centimeter on each side. I took 2 times 0.5 and I got 1. Took all of my sides and multiplied them by the scale factor. That's the important piece. You need to multiply by your scale factor. It's making that size either smaller or larger. Now, if you look at this, my scale factor is 0.5. Notice what happened to my triangle. What happened to the sides? It got smaller. Think about that last problem when we had a scale factor of 1.5. What happened to the sides? They got bigger. Just for a helpful hint, as you look at this, we didn't discuss this yesterday. Not sure why I put that up there. It says a scale factor between 0 and 1 reduces a figure. It gets smaller. Scale factor bigger than 1 enlarges it. It gets bigger. Okay, so if you want to write that down, that might be helpful just so you can quickly check your work. Quickly check your work and go from there. All right, moving on. All right, so now this is going to be, we're dilating the figure below by a scale factor of 2. Before, if I gave you a length of something, a length of a side, what did you do with the scale factor? Multiplied. You multiplied it. Okay, now what's going to happen is I have a scale factor of 2 and I'm given a point of 4, 8, 3, 2, and 5, 2. I'm going to change my AB into triangle A prime, B prime, C prime. And I'm changing all of these and multiplying each of these by 2. Just like I did on the previous problems. I need to multiply both of my points, and I'm going to get 2 points. I'm going to get an X and a Y, but I'm multiplying everything by 2. That allows me to ensure that this shape is dilated. The shape will not change at all if I dilate every single point, all X's and Y's, by the same scale factor. But the shape will get larger. It'll get larger because this number is greater than 1. So I take my points and I'm multiplying it by 2, and I get 8, 16. Multiplied each of those by 2. I get 6, 4. Last one, I get 10, 4. My shape did not change whatsoever. Size did. By multiplying all of those by the same factors, that's what I find. And I put it in, notice I put it in point form. I gave you coordinates because it asked me to find these vertices. That's where my vertices are. If I connected those dots, I'd have a triangle. Beautiful. Try this one on your own with the scale factor of 1/3. Try 1/3 scale factor. Find my image. All right, so what am I doing to my pre-image? Well, I'm taking it and I'm finding my A prime, B prime, C prime, and I am translating dilating each of these by a scale factor of 1/3, multiplying everything by 1/3. And if I do so, my size will change, but my shape will not. Okay, so I take 3 times 1/3, my answer is 1. 9 times 1/3, my answer is 3. I took each of these x and y's to get my points. 9 times 1/3, 9 times 1/3, I get 3. 6 times 1/3, I get 2. 6 times 1/3 again. Oh, hey, I just did that one. I get 2. And then I get 3 times 1/3. Hey, I did that before. I get 1. And here are my new vertices. 1, 3, 3, 2, 2, 1. And I'm done. Done with that problem. Just multiply by my scale factor. Okay? All right. Now we're given this. Okay, it says dilate the figure by a scale factor of 2. What are the vertices of the image? Now, remember when I talked about pre-image and image? Was image my first triangle or my second triangle? It's my second triangle. It's what happens after the scale factor. Okay, so notice here, I don't have any, I don't have my coordinates. So guess what I have to do first? Find my coordinates. So if I find my coordinates, then I can dilate my figure with a scale factor of 2 and find the vertices of my image. So I start with my pre-image, which is right here, pre-image, and go from there. Okay? So what I want you to do is identify the coordinates, multiply those by a scale factor of 2, find the vertices of the image, that new object. Don't have to graph it, just find them. And go. All right, so the vertices of my pre-image of ABC are going to be 2, 1 for A. B is 4, 1. C is 2, 3. What do I have to do with all of these points? Well, I have a scale factor of 2, so when I go straight across, when I change these into my prime here, my image of A prime, B prime, C prime, they are dilated with a scale factor of 2. My new points, my new vertices would be 4, 2, 8, 2, 4, 6. And I am done. Okay? I found my new vertices of my new triangle right there. Okay? So careful when you're looking on your directions when you get to your homework later on. Not tonight, not doing your homework tonight. Okay, this was your homework. And just make sure you're answering what you're finding. Are you finding your vertices, or are you finding the side lengths? Okay, so they might be switching back and forth. All right, that's all I have for you today. I hope you have a wonderful day. Enjoy it. Talk to you later. Bye.